Alright, here in Chapter 10 we've been learning about roots. Square roots, cube roots, all sorts of different kinds of roots. And now we're at the stage where we're going to take that topic, that roots topic, and we're going to start doing algebra, actual equations that involve roots. For historical reasons, back in the day, what we call roots nowadays, the actual technical term for them are radicals. So equations that have roots in them, their technical name is radical equations. And unfortunately, that word radical has taken on so many other meanings nowadays that it's almost become a joke. In fact, I found this on the internet, this little joke about radical equations, haha. And although it's, mildly funny, I actually thought that this would make a pretty good example for us to start with. If you take a look at this equation, this square root of x plus 3 equals 6, this equation serves pretty well to allow me to teach the basic ideas of 10.6. There's really three key steps to solving these things, and for the most part these steps are pretty simple. So, the first step to solving this kind of thing, step 1, is to isolate the root. Get the root by itself. So in this case, for this equation that we're looking at right now, square root of x plus 3 equals 6, the first step we'd have to do is subtract 3. And that's easy to do. And then the second step, although it's technically a new step, step 2 is technically something we've never done before in algebra. It's really kind of obvious and sort of instinctive. The next step is to square both sides of the equation. So here you would take on the left side and the right side, and you would put parentheses and an exponent of 2. Of course, think about it. If it wasn't a square root, if it was a cube root, you'd have to cube both sides. And if it was a fourth root, you'd have to raise both sides to the fourth power. But once you know how to do square roots, the higher roots all kind of are the same idea. So we don't really spend a lot of time talking about equations with higher index roots, because if you can do these ones, you can do those ones. And you can see what the answer comes out to be. Square root squared, you end up with x. 3 squared, you end up with 9. And there's your answer. So those two steps were fairly easy in this example. What we have to practice is slightly more complicated examples. So let's next take a look at this problem here. Remember what the steps are. Step 1 is isolate the root. So that means we're going to subtract 5 on both sides. And you can see that gives us a little bit more complicated thing this time. X minus 5 equals square root of x plus 7. And then the second step is to square both sides. And this is where people start to have some trouble. The rule is easy to remember. Square both sides. That's real simple. But people don't always actually understand what they're saying when they say those words. When we say square both sides, that doesn't mean the same thing as square each individual piece. So it's not like you're going to get x squared and 5 squared and square root of x plus 7 squared. You don't square piece by piece. The rule is square both sides. So what that means is it really does help to put parentheses and square. Because the key thing is, this here, you're going to have to multiply this out. You're not just going to square the x, and you're not just going to square the 5. You're going to have to do x minus 5 times x minus 5 and FOIL it out and collect like terms. You're going to end up with a more complicated left-hand side than you might have thought. You're going to end up with x squared minus 10x plus 25, if you square it out properly. On the right-hand side, things are actually simpler because you don't have to FOIL anything out. On the right-hand side, the square root and the square, they just cancel each other out. You just get x plus 7. Piece of cake over there. Nothing to it. The other thing that can happen is what we see happening here, and that is the equation you've created once you've cleared out the roots. It may be a more complicated kind of equation than the one we did a second ago. Like here, this is a quadratic equation. So now mentally we sort of change gears and we think, okay, now it's a quadratic equation. How do I solve a quadratic equation? And with quadratic equations, what you do is you get it equal to 0. So I'm going to subtract x on both sides. I'm going to subtract 7 on both sides. And I'm going to have x squared minus 11x plus 18 equals 0. And the next thing you have to do with quadratic equations is you have to factor them out. So you take a second, you factor that out. Luckily, it's fairly easy to factor. And we get this. And you know how to break that up into two equations. X minus 9 equals 0, x minus 2 equals 0. You get two answers, x equals 9 and x equals 2. But I think instinctively you might know there's something else going on here. And I kind of gave you a hint at the beginning of this video. I said there are 3 main steps, and I've only taught you 2 so far. So there's got to be something missing. And what's going on here is these equations that we're looking at now, they have a thing that's going on that's very similar to something we saw back in Chapter 6. Back in Chapter 6, where we were doing fractions, rational equations, you could do everything right. You could do all the right steps, but then at the end, the answer that you had, it still might not check back in the original equation. So, back in 6.6 of Chapter 6, the rule we came up with was you had to check the answers all the time. It wasn't optional. Checking answers was not something you could choose to skip. You had to write it out or you wouldn't get full credit on a problem. Well, the same thing holds true here. Let's go ahead and take each one of these answers and let's try plugging them into the equation that we started with and see if they work. So I'm going to take x equals 9 and plug it in here. I'll take x equals 2 and I'll plug it in there. And let's see what we get. So x equals 9 gives us 9 equals square root of 9 plus 7 plus 5. That's supposed to be a 9 there. Let me write more clearly for people who are trying to watch this at home. Over here, if you're plugging in 2, you've got 2 equals square root of 2 plus 7 plus 5. And when you actually work out the arithmetic, 9 plus 7 is 16. Square root of 16 is 4. 4 plus 5 is 9. Yeah, this one works out just fine. It checks no problem. So x equals 9 is an answer. But over here, 2 plus 7 is 9. Square root of 9 is 3. 3 plus 5 is not 2. That one doesn't check at all. So here, just like what we had back in Chapter 6, the rule is going to be you must check your answers. Checking answers is not optional. So I'm going to make a big deal about that here in the video. You must check your answers. If you don't check your answers, you will not get full credit. And that means you have to write it on the test. When you're taking the test, if this isn't written on the paper, I'll give you like maximum half credit on the problem, even if everything before that was right. So make sure you check your answers to these things. All right, one last issue, and this isn't a new step, so the steps are still going to be the same steps. It's still going to be isolate the root, square both sides, check your answers. Those are still the steps. But these problems can get a little more complicated in one key way. And I do have to warn you that these advanced radical equations that we're about to take a look at, these are probably legitimately the most difficult type of problems algebraically you're going to run into in all of Algebra 2. So do not pretend that you can study this and learn it in 5 minutes. This is a tough topic. So I'm going to give you the massive headache warning. I love that picture. And look at that picture there. Whoever the photographer was, their timing was perfect. You can see the shock wave going through the guy's face as the ball pounds into him. So you know he's about to have a massive headache, and that's the warning. We're about to have a massive headache here. This is a long, complex process. If you don't take it slow, you're going to get hurt. So please take your time with it. So first of all, the first step is to isolate the root. Well, we've already got a problem. There's 2 roots. How do we isolate the root? Well, here's the advice that I give you. Isolate whichever is the more complicated root. So in this case, if I look at these two roots, the one that looks more complicated looks like that one with the 3x plus 4 in it. So I'm going to isolate it. That means I'm going to take the square root of x plus 2 and move it over to the right. Subtract it from both sides so it ends up on the right side of the equation instead of the left. So isolate a root. And my suggestion is the more complicated root. Although, honestly, it doesn't really matter. You can isolate either one that you'd like. You'll get the same answer in the long run. Then, next step, square both sides. And I strongly, strongly urge you to actually put parentheses, actually put an exponent of 2. Even if you think you're the best thing ever in math, this still helps you do the key steps right. And these are the key steps. These are the hardest steps that this whole problem requires of us. We have to actually FOIL out this times itself. And we better do this slow and careful because this is the place where people can really botch things. So I'm going to very carefully work out first and outside and inside and last and make sure we get it all right. So first would be 2 times 2 is 4. Outside would be 2 times negative square root of x plus 2. So it would be negative 2 square root of x plus 2. And when you do the inside, it's the same thing. So also negative 2 square root of x plus 2. And yes, we'll collect like terms in a second. And then last, we have negative times negative, so it's positive. And you have square root of x plus 2 times square root of x plus 2. But if you think about it, this part actually works out kind of easy, doesn't it? This is really square root of x plus 2 parentheses squared, which means the square root and the square cancel each other out. We actually end up with x plus 2 there. No root, no x plus 2 times itself or anything, just plain x plus 2 there. And then don't forget to collect your like terms. If we've got 2 of those twice, so that's 4 square root of x plus 2. And hey, there's like terms here and here also. Let's not forget about them. So when you're all done FOILing out that right-hand side, we end up with, it looks like, 6 minus 4 square root of x plus 2 plus x. Now that's how the right-hand side of this equation works out. The left-hand side is much, much simpler. Square root, square, just cancels out. You get 3x plus 4, no-brainer. So no work that you got to show over there by comparison. If you followed me so far, if you've gotten through this much of the problem without losing track of where we are or anything, the good news is you're over the hard part. It's kind of downhill from here. There's a lot more steps, but they're nowhere near as bad as the steps we just finished. So let's continue on from here and see what happens next. So what happens next is, you may notice, there's still a root in the problem. We got rid of one of them, but the other root is still there floating around. So it would be pretty natural to wonder, why did we do all that work and then we just ended up still at an equation that has a root in it? Well, what we do is we do it again. There's a root in your equation, so isolate the root. Isolate the root by subtracting the 6 and moving it over to the other side, and subtracting the x, moving it over to the other side. So you're subtracting x and you're subtracting 6. You're going to end up with this. And square both sides, just like we did in the previous problem, and we did previously in this problem. Here's the tricky part. FOIL correctly here. Don't just square the individual pieces, actually FOIL the thing out. You're going to get 4x squared minus 8x plus 4, if you FOIL it out right. Over here, when you're squaring this, you square the negative 4 and you get 16. And you square the square root of x plus 2 and you get x plus 2. But don't forget that 16's got to distribute into the x plus 2. Just like the example we did previous to this one, what we're looking at now is a quadratic equation. So we're not done. There's still several steps to go. We have to take this quadratic equation and get it equal to 0. So that means I'm going to subtract the 16x squared, and I'm going to subtract the 32. So let's see, 8x minus 16x, we get negative 24x, and subtract 32 from that, we get negative 28. And then we got a factor. And I would suggest, I think this will make your life a lot easier, let's factor out the 4 first. Just so that that's not a problem anymore. There's a common factor. And don't forget, you should always do common factor first. It'll make your life so much easier if you just get in the habit of doing that. And then the rest of the factoring is pretty simple. Minus 7 plus 1. So the two answers we've got here appear to be, and I'm using my words very carefully there, the answers appear to be 7 and, oops, not negative 7, 7 and negative 1. But remember, I said this a minute ago, you always have to check your answers. So here was our original equation. We're going to have to take x equals 7 and plug into this thing, and x equals negative 1 and plug into this thing, and see if they work. And I got to warn you, they might both fail. This might actually have no solution. They might both succeed. So you really can't afford to check only one of them. You've got to check both of them. One might work, the other might work, maybe neither of them work. So let's try 7. 3 times 7 is 21. And square root of 7 plus 9 is 9, and square root of 9 is 3. 21 plus 4 is 25, square root of 25 is 5, and 3 plus 5 is not 2, so that's 7, that is not an answer. Over here, we try negative 1, and at first, a part of you might be saying, I can't put negatives into a square root. And you're kind of right, except here, they don't actually stay negative for very long. Like this just ends up square root of 1, and so does that. So plugging negatives in isn't really a problem, as long as you don't end up taking a square root of a negative down the road a little bit. Notice in this case, this checks just fine. 1 plus 1? Yes, indeed. That's actually 2. So here's a piece of really good news. If you were able to follow that entire problem that we just worked out, even if you had to go slow, because I have to go slow. Everybody has to go slow when they're working these ones. But if you were able to follow it all the way through, you've just now been able to handle the toughest type of equation you're going to learn in this entire class. So, congratulations.